I'd like to go back to Speed Muller, if Speed has joined us yet. Speed?
I'm here. Good evening.
Okay. Great.
Ready to go?
I will turn it over to you, sir.
So the next presentation is a little bit more technical. So this is typically where I give the presentation at 2 p.m. on a train convention and everybody falls asleep. So if you take a short nap, I can't see you, so don't worry about it. What I want to tell you about today is mqTrains, inexpensive layout control with Wi-Fi, not necessarily required, but it helps because the parts are kind of small, using a new technology, not so new technology, but more get to know technology in the IoT world called MQTT. So, oh, got to share, right? Share the screen.
Speed who?
Everybody can see that?
It is there.
Yeah.
Okay, looks like we're live. So who is Speed? Well, he's the guy at the bottom of the helix on NMRAx, born and raised in Namibia, southwestern part of Africa. I live in Murphy, Texas, which is just northeast of Dallas. And I modeled the Transnamib, which is our railroad in Namibia, as the TX number. No, the TX is not Texas. The TX is trans, like RX and TX is transmit and receive. That's where we got the TX from. Only later did we move from Boston to Dallas. So it's up here in a 20-foot by 20-foot room in N scale. And you might ask, what's about the weird nickname? Well, if your parents called you Gert and you moved to America and they call you Gert, and then you figure out it's the short for Gertrude, then you have a problem. So if you cannot read fast as a modeler, I can type faster than most modelers, and that's why I'm called Speed. Thank you to JMRI for getting me that nickname. Okay, so what you're going to see today, mqTrains, what it is, why and how, some inexpensive components that we use, a quick overview of MQTT itself, and how do you use mqTrains with JMRI, and then there's some people that don't like JMRI, so how do you use it without? Okay, I also have to give some credit to my three amigos, Brad Anderson in secret behind the scenes doing most of the testing, but the two big developers with me has been Joe Davidson and David McMorran, the one in Austin covering all of Texas, and David McMorran is covering all of Down Under. So what is mqTrains? It's started as firmware, where we would just write code for these ESP8266 microprocessors. Now, a little bit of an introduction. You might think, is this an Arduino? No, it's not. It's a different company, different chip, but they have a Wi-Fi part to it. Oh, ESP32 cameras. Yes, it's similar to that, but it's the baby brother of those. The ESP32s came a little later, and since the tools and software is not all completely there yet, we claimed 3 years ago, this will work perfectly on the ESP01s and ESP01S devices because they have 8 pins that are in fixed locations. So you can plug them in any board we make. If you pick another ESP, now you have to worry about where the pins are on the outside of the board, and you have to make sure they connect to what you want them to connect to. So lately, we're also providing the hardware designs that will show you how to interconnect these things with the hardware that's already available on Amazon and AliExpress and eBay, and wherever you go with Google will take you to a very inexpensive board that could drive 16 servos. Naming servos, these things can do solenoid turnouts, stall motors, control outputs like lights. You can sense sensors, sense push buttons, and the best part is it's all free. Now, it's not completely open source yet because we have to clean up some code before we show it to you, but you can download the binary file, you can program it, and if you follow the instructions on how to hook it up, then you might just have something that controls your layout without wires. So there's an example. That little board on the far right where the power supply comes in from the top is a mere $2, and where the colorful connectors are, that's where you plug in up to 16 servos. Now, 16 servos, yeah, that's like on my layout includes a windsock. It can do a little crane to push something up, but mostly we would like to move our turnouts so that we can say, train, you can go to the diverging route or you go straight. So imagine 16 servos plugging in there. And then on the far left-hand side, there is the ESP01 without the S little board. That's a $1 microcontroller with a Wi-Fi interface for you to play with. Now, if you have a breadboard, you want to wire these things up yourself, you do that. Or if you would like to order some PC boards off some internet company where you can download or upload the Gerber files to, then you can also solder your own little board in the middle there for a mere 37 cents plus maybe $4 more with more components. Okay, so why do we do this? Well, there are many inexpensive things out there to control your layouts. It's fairly easy to pick which ones. It's a little harder to know how to hook them up together. And when you get to the point where you need to write code to make it work reliably, then most people find another way. And then the dollars goes up and you have to pay that. So for us, the main objective here is to make this technology available to everybody. And all we need to do is show you how to hook it up together. So less wires, less time, less cost. Oh, I also have a 3-foot rule that when you are at a problem on your layout, then if you stick your left hand out or you stick your right hand out, you should be able to solve it within arm's reach. And that's my famous 3-foot rule. So no long wires to walk around the peninsula or duck under. So here's the inexpensive parts that I'm talking about. You can see a ESP01S, the newer one is $1. The PCA 9685, I saw some for $2 last night when I did the research for someone's little project. The buck converter that's shown there is 50 cents, and a 9G servo motor you can get from almost anywhere for $1.20. So if you buy 16 servos and you ignore the cost of the wires in between these things, for $23.70, you can control 16 servos or 16 turnouts. Isn't that the price of a torus machine? Well, nothing bad about torus machines, but 1 versus 16. And let me tell you one more secret. Once you have this all up and running, your phone can control it. Your tablet can control it. My dispatcher in Scotland can control these 16 servos. When you buy that torus machine, how are you controlling it? You haven't bought the $3 double pull, double throw rocker switch yet, right? You haven't connected it to JMRI yet, where these things includes all of that. Okay, so for the IO side, that little MCP 23017 is shown upside down there. The reason is so we could read the labels. And it shows you a button on the left and an LED on the right. So those are the IO kind of things that we can control, as well as reading block detectors from occupancy sensors on your railroad. So what do you need? Wi-Fi for these ESPs. If you were to put this code, the code on a Raspberry Pi or some other kind of computer with inputs and output pins, especially an I2C interface, then you could go with wired Ethernet as well. So your JMRI computer does not have to be Wi-Fi connected to the router. It could be connected by a cable. We tested 22 nodes, is what we call them, these little boards, on that very old and famous WRT54G router, as well as the DIR 655, that's also more than 10 years old, and the Linksys N600, which costs a mere $30 today. And I know all of you are getting these new mesh network things. They just run even better. I have about 42 nodes up and running here on the layout. There's one in action, the signals right here, and the turnout control right behind me. And there's 30 more planned for the layout to get it finally up and running. Okay, how do you set this up? You need some computing device because there's a little piece of software that we need to run that's called the MQTT server. So you can think of it as your mail server or the innermost thing that has to remember everything, because we publish messages to it and we subscribe to get messages from it. So that would need to be installed on either a Windows, a Linux, a Mac, even a Raspberry Pi computing device. And you need to connect that to the Wi-Fi router so that all these other devices can connect to it. So simple install Mosquito or any other MQTT server or broker. Used to be called brokers, now it's called servers. On your Linux, Mac, and Pi, you do a simple type in sudo apt-get install Mosquito. On a Windows computer, you download it from mosquito.org, and you unfortunately, in Windows, also have to configure your firewall to let messages come in and out because security is a concern there. And then you need to find out what is your computer's IP address, because these little devices needs to publish messages to it, and it uses the Internet of Things, and it needs to know the Internet protocol address. So either on a Pi you type in ifconfig, will tell you the numbers, and on Windows you do ipconfig, and it will give you the numbers. And these are typically things like 192.168.something.something, or what I always tell people: if you buy a new router, configure it to go 10.10.10.something, because 10.10.10 is a lot easier to remember than 192.168.177 and then some number that it's going to give you a device. So here are the little nodes you can see on a breadboard. David built the 16-channel servo controller. It's plugged in, pointing down, so it's not shown as pretty as it should, but you can see where the servers go into. So how do you set this up? You connect all these things together. The LCD there is optional. That's just if you don't have another way of finding your device itself's IP address, then the LCD would point that to you. But you can then move the LCD to the next device and the next device as you set them up, and eventually you don't need the LCD anymore. And you connect, when you power this setup on, you use your phone to connect to it, or your tablet, or your laptop, or your wireless device, and then you go to the 2.2.2.1 website, and you select the quick start button at the top there. Once you get the screen for the quick start, you have to pick a unique number for the board, because they all have to have their own identities, so that you can say board number 3, please throw a turnout, or board number 5, please throw a turnout, as they are in different places. And that IP address that I told you to get, that was the 10.10 or 10.10, that in my case for the MQTT server. So that original computer that you installed Mosquito on, you need to put its address in there. The default port is 1883. The base topic, you would put your own layout name there. In my case, it's txnumup/mast is a good one, because this board is for the mast, or turnout, or sensor, or IO. And you need to remember what you type in there, because if you use JMRI or another way to control this with, you would need to supply that topic name there as well. I always tell people, imagine it's an email address. You need to know someone's email address if you want to send them an email, right? So the topic is where the messages will go to. And then your own Wi-Fi SSID name and the password. And we are quite security conscious. So whatever you type in there, you will never see again. So make sure you remember what it is. Okay, what is MQTT? You might hear about this. It's a technology that was developed quite a number of years ago when they built all these pipelines and had to monitor them. So in order to send small pieces of data with not a lot of bandwidth and not a lot of data at a time to some satellites, so someone could monitor an oil pipeline or a gas pipeline. That's when it was invented way back when. And it only became popular just the other day when we started saying, Alexa, please turn on the light. Well, it's not an Alexa technology, but the light is connected to something that it will tell it with a message saying, hey, turn yourself on, or is the garage door open? So how those devices interact with each other and the computing devices, more than half of them uses MQTT. So very lightweight protocol. You know things like HTTP, FTP, and SMTP is for emails. Well, now we have MQTT. So just another 4-letter acronym that's not important to anybody except for the people writing the code inside here. So it's a messaging protocol. Like I said, you might have heard of IoT. It's using a broker. They call that now a server, and things connect to it, and it's subscribed to these topics. And when someone publishes to a topic, then those who are subscribed gets the messages. So you can imagine when you push a button, then it publishes a message to a topic, and whoever is listening to that button will then get it and say, hey, because you pressed that button, I need to move this turnout or toggle the state of this gates or rolling doors that roll up and down, that kind of thing. So, but in most modelers' lives, the first thing to do is to move turnouts. So we send thrown and close messages to make turnouts move. The cool thing is that with a single configuration line in your MQTT or your Mosquito broker, you can bridge this to another Mosquito instance, and that gives people access to control your layout or parts of your layout, whichever parts you give control to. And that's how I use my panels to give Gordy and Scotland access to throw turnouts here on the main line as he's helping trains across the railroad. Now, JMRI also have MQTT, and the very next release will also have signal mast. Sensors and turnouts already exist in it. So you could have someone in another part of the world connect with his JMRI and his own view of it. You give him the files and it looks different for him than it looks for you. And whatever he clicks on publishes, and whatever messages he subscribed to will show up on his side and show an occupancy detector go active or inactive. Now, the messages travel using TCP/IP, and that's why we're using Wi-Fi. But if you had wired connected devices, like I know of a guy that has more than 10 Raspberry Pis, then you can use the same protocol, and all his Raspberry Pis are plugged in with Ethernet cables. So, okay, so the messages have a payload, and that's the email part. You can even send images with this, but we like to keep it small and short because the devices are not very power hungry. So in order to keep that lightweight, we say thrown or closed, approach, semicolon lit, semicolon unheld, or active or inactive. And then the topics are the things where it gets published to. So a typical topic would be TX number, turnout, and then the board number 0201. And then 01 would be that first slot on the PCA board where you plug the turnout into, the servo motor into. And in JMRI, it would be called MT0201/01. In the second case here, I did not verify how the next JMRI is going to show you the system name, but it will have the typical signal mass name that shows the type of signals it is. And then in the parentheses, it would have the same topic structure as we have for turnouts and sensors. And lights and sensors and IO things, similar idea. Okay, so mqTrains of JMRI. There's two awesome NMRAx clinics that you can go look up on September 26th and April 24th. David McMorran gave those clinics. And on the txnummup.com website, there is a list of all 377 NMRAx clinics. So you just do a search there for mqTrains. And while you're there, also search the ones for LCC or DCC, and you can get all the information down there. I will put a link in the chat here as soon as I stop talking. Okay, so you open up the preferences in JMRI, you select a new connection on the connections tab, and you put your IP address of your MQTT broker or server in there. Then the MQTT channel, that's where you change the My layout to TXNumUp, whatever you like. And if you decided to go with servos, I would change the turnout to servo, but the default is now turnout. And further down, you can see signal mast. I've just been using mast, so you have a way of configuring those things right here. And then once you go to the tools, tables, turnouts menu, you can add a new turnout, give it some unique username, and the hardware address would be 0201/01 as in the example before. Okay, so these messages, this is the technical part, so we'll skip over this in a quick way. JMRI would publish, close, or thrown to the MQTT server. The MQTT servo board would subscribe to that specific topic. It would get the subscribe. Because it's subscribed, it gets the message and it says thrown for turnout number 1, and then it moves turnout number 1 to the thrown state. What I didn't show earlier is once you have all these things powered up, you go and configure every servo on how far to move. And you go configure every pulsed or solenoid turnout, how long to be on and how because you want to keep a solenoid powered the whole time. And if you do set the time to 0, then you can drive a stall motor like a tortoise machine, and it will be on all the time, whichever way the thrown or closed is set. And you configure is thrown this way or is thrown this way. That's all done in the little HTML page of the device. And then when you touch an IO button, then it publishes. And since JMRI is subscribing, JMRI will show that that sensor went active. And similar thing happens with when there's more devices with inputs and outputs. They all send and receive messages as needed. The really cool thing that we have with the MQTT broker, that is if you set these messages to retain, which we do by default, then when you turn the layout on and that servo board turns on and it subscribes to the broker, it gets all the messages as it had them 20 days ago. So you don't have to run a script to say, this is the new route or this is the main route so that all the signals can do their things. No, the broker remembered where the turnouts need to go, so the turnouts immediately go to where they were last time. So no more route running or start of day problems like they call them. Okay, without JMRI, here's a view of my hump yard. What you're looking at is a tablet with a web page, and it's using JavaScript code in the background, which big word, but it's already all done. All you need to do is say which buttons go where and what are their addresses. So this one here is a little special that when you touch one of those 7 buttons there, you're selecting which track do the cars need to roll down the hump yard. So it's more than one turnout gets thrown or closed when you touch one of those buttons. So it's a little different than what you'll see in another photo where you simply touch the diagram. So here's what the dispatcher sees. So you can see that there are little orange circles by the turnouts, and they go to places, but the dispatcher doesn't know where they go. There are even more turnouts in town that he can control because we only want to give him access to the main line and the sidings so that he could get trains to go past each other. Now, the yard here on the left by the helix, he's seeing all the turnouts simply because the helix is double track going down, and therefore for him to get a train through the yard there would be only one turnout that I wouldn't show, and that would be the one where track 1 connects to track 2. So I decided to just copy the whole panel and show that to you. The ones with the gray, nobody can touch and they can't move, even though they are installed. And on my phone, I have another view. I can touch the button and run a train around the circle at the bottom of the helix. The little red lines you see there, those are occupancy detections that once that sensor goes active, the track symbol will change from white to red. So the dispatcher can also monitor where the trains are. Here on the top right, you see the panel for the town. Let me just quickly peek back. So at the very top right, you see Okahanya, and there's 2 crossovers and 2 turnouts on one on the siding, one on the main line. And if you look at the real screen for Okahanya, there's a whole bunch more turnouts that the local guy can change, which the dispatcher cannot see. The double blue line is the main line, which you also see at the bottom there, second line from the bottom. So when you touch those orange circles, then the turnouts change over. Oh, here's a nice view of it. You can see there's a train leaving Okahanya to the south, and nothing else is occupied in town. The really cool thing about this is when you, the owner, who's not operating because you got to fix all the problems. When I sit here in the helix and I'm helping the dispatcher and I hear somebody is having a trouble derailing over some points, then I bring up the panel on the computer screen here. I'm like, yep, I know what he's doing. And then you just click on the turnout, fixes the problem. He doesn't derail anymore. And he doesn't even need to know that, the angels helped him out. So one day I will put back the little buzzer so that when you do run against the points that you get the loud beep to tell you, you got a short. See how easy we got by taking all those things out so people now just can run trains without nobody knowing what mistakes they're making? I think we need to put those back. So a few more examples, solenoids and stall motors. There's the Cato turnout at the bottom that gets a pulse out of that L9110S board, which is available on Amazon for, I think, $1.50. So with this little interface board here and Arduino Nano to do the timing, we can control 8 turnouts. And if you set the timing to 0, then that stall motor, the tortoise machine, will stay on whichever way you tell it to go. Signal masts, we believe in these things called pixels. So you have seen these addressable LEDs. You see the example I show there in the middle photo is actually 3 masts. Believe it or not, there's a clear, there's an approach, and then there's a stop. And you need to imagine those being broken apart and soldered to sticks and planted down the layout. And in the right screen, I show you that if you already have your signals installed with LEDs, then you can buy these WS2811 chips. And since it has a red, green, blue channel, you solder your LEDs to those wires. And now when we set that mask to have blue on, then you would have the third LED that you solder in. Might just be a lunar one or a red one, or actually a blue one. It doesn't have to be red, green, blue, because these pixels on the left can go what they call 16 million colors, even though some of them are just darker versions of others. But you send data 255 red, 255 green, 255 blue, and that makes the color that they show. So the ones on the right is just as inexpensive. And like I said, you solder your own 3 LEDs to it, and you string them up into a wire. And then just one of those pins of the ESP, the purple one on the right side there, is controlling the whole string. And right now we can control up to 50 masts, which includes, like the top left above me here, a Pennsylvania signal that has 7 pixels on it. Now, in this case, it's kind of a waste. The blue never turns on because it only goes yellow. So there's only green and red on at all times. How do you get started? Well, I suggest you buy yourself an ESP8266 starter kit. I think the price is $14.99. And you go over to mqTrains.com. You can read all the PDFs that's there. You buy some parts from Amazon, PCA 9685 for $2 and a few servos. You plug them in, you download the code in, you configure it, you set it up, and you're off to the races. So I hope I didn't rush too fast through this. They gave me half an hour. The only bad question is the one you did not ask. So, Jim, any questions?
Anybody have any questions for Speed?
The 3-foot rule you were talking about, is that a limit to the servo wire extensions?
It is not a limit. Are we on the air? Because I want to tell a truth here. So don't record this part. I have one servo that is controlled from 10 feet away. The bigger problem with these servos are that we use these short little extension cables. So you plug one into another, into another, into another, into another. And by the time you get to the 5th one, your servo is doing the and you're like, uh-oh, because very few of us is willing to solder 3 pins to 3 pins and run it all 10 feet. Now, what is the limitation really? Is it that you are too stingy to spend another $5 to control that servo over there, and maybe have a guy chopping a tree down right next to him, or a gate opening up and closing, or maybe a windmill changing direction? Why would you rather not avoid the 10-foot problem and do a few more things over there, where we all know that we always stuff the board up to the very last one, so 5 years later we cannot make it grow because we left nothing for expansion. So almost all my turnouts, even this one right here above me, is only 12 up to 12 turnouts plugged in. There's always 4 slots more where I can put something into to do something else.
Speed, this is Jim Murphy. I have a question. You showed block detection on your main panel, which was on a display. What kind of block detection do you use? Is it simply an on-off detector, or do you go high-low on a pin?
So they are physically BD20s, which I I made my own so I could have a screw hole through the board, because I hate it when you get to someone's layout and the double sticky tape is either on the PC board or the double sticky tape is on the layout. It's somehow the three never stay together. So,
Understood.
so I made my own little boards, and because I'm a debug freak, when you turn the layout on, every block that's not occupied has a red LED that turns on. And as soon as the train goes over it, the transistor shorts and that LED dies. It pulls the line low and it tells the little board, hey, there's someone here. So,
Okay, so what pulls the line low? Is it current that you're detecting?
It's current through the
Current,
through the transformer.
And
but
that's on a BD20.
It's like a BD20.
Vaguely familiar, but I haven't looked that one up
Yeah.
ever. So,
but you could use anything that makes a 0 to 5 volt high or low. The IO board itself is a digital control device. So if you go above 2 volts, it sees it as a high, and if you go below, I think 1.5 or something, then that's a low. So you can invent anything. Like the easiest thing is to do a pull-up resistor with a push button, and if you push the button, that point goes low, and the board sees something different than the high you just had.
So you could also use like an optical detector with an infrared LED pair.
Correct.
The same thing to get you 0 to 5 volt or something signal to activate it.
Exactly.
All right, thank you.
Okay, so I see a few questions here from Edward. Why are you using Wi-Fi than using Zigbee or Z-Wave? So a Wi-Fi router is $29. A mesh network system is $120. If I had to create a Z-Wave or Zigbee controller, now I also have to supply that when someone wants to go mqTrains. So instead of me hacking into a SmartThings device owned by Samsung and tell everybody to buy a SmartThings device or sell my own Z-Wave or Zigbee controller, Wi-Fi has the benefit that TCP/IP protocols go through it, and there's literally a computer on the other side, and these things are tiny little computers that sense data just like any other TCP/IP thing. Now, yes, there are Z-Wave things carrying TCP/IP packets. There are Zigbee things doing similar things, but instead of me being in control over the mesh or how they assemble and making sure who's where, we went for the $1 ESP01 board that gives you 8 pins. That's always in the same location. Can you control locomotives? You certainly can, but I would not like to, because there's a quality of service that makes sure that your board will get the message, but it doesn't tell you when. So all of us, when we turn that throttle down to 0, we want the engine to stop. We don't want to stop it 3 seconds later. Now, what I always explain to people is when my dispatcher in Scotland clicks on a turnout, when do I expect that turnout to move? I don't know when he clicked on it, right? He certainly is not clicking on it while my engine is already on top of it. Imagine the signal head that needs to change. I just talked to him. He gave me a track warrant. I'm writing down the last part. I'm gathering all my tools and my stuff. I'm ready to go. And now I look at the signal. So I have literally about 5 seconds since he clicks on it from when I'm going to need to see the signal. Now, I know there's some of us that monitor those signals with an eagle eye, and you're going to count the seconds since he clicks and you get the signal. Well, okay, let's play smoke signals then, and you're happy that it happened within half a second, because that's a typical reaction time that I've seen when we test these things. I tell Brad in Australia, click on the turnout. I want to see how fast it moves. The turnout also takes 3 seconds to get to the other side. But when you get to locomotive control, you want those 2 engines or 3 engines or the one that's in the rear of the train need to move in unison. So I much rather stick to LCC for that. Question from YouTube. Are they going on NGINX, which I've seen once before? I'm running a small Apache server. It serves the JavaScript library called Paho, Paho.js, as well as the Canva panel in which those elements are drawn on. So it is just a simple web server. JMRI also gives you a web server, so you could also look at any panel that JMRI has through any phone or web connected device. What are your thoughts on LCC? I was a big proponent of the Merck C-Bus system, and there's still a part of it underneath my layout here controlling the staging behind me. But when I only had 6 months left to get this whole railroad up and running, I didn't have enough time and energy to deal with the wiring that is involved in a CAN bus. Wonderful technology. I mean, if you have to control something 100 meters away, I would definitely go with LCC or CAN bus versus doing something Wi-Fi. Because as an electrical engineer, I hate batteries and I really hate wireless things. So none of my throttles are wirelessly controlled. All these things have cables to them. Because if it's not plugged in, it's not on, and I don't have to worry about the batteries, right? And batteries always die in the middle of the operating session, right when you're helping someone else, then George wants a battery. So I think LCC is a good way to go. I just wish there were 10 companies making products for it, so the price would come down a little bit. So the timing was off for me, and I went this way. So